Go.
Hello. Thanks, guys, for coming today. And listen, I'm going to talk about ocean energy. I have these sheets so you can follow along with my PowerPoint. Did you guys know that we're in the middle of an energy crisis? The cost of energy is escalating, and the amount of CO2 is at dangerous levels in our atmosphere. And we got to be careful because the ozone, which protects the Earth, is getting damaged. So the scientists across the world are trying to find new ways to create energy that's environmentally safe and cost efficient and renewable. Wouldn't that be great? So you wouldn't have to go out and see warehouses or all that smoke coming out in the sky. You'd like to see the nice blue skies. Wouldn't that be cool? Well, one of the things we're going to talk about is the ocean energy. We already work with solar. You see the solar panels on some houses. You see people with wind turbines, like in Eastern Oregon, blowing. And so you see the dams across the river. Well, that's a renewable energy. What the scientists are looking for now is to work on the ocean. Did you know that if we had tapped into 2% of the ocean's energy, we could power the whole world? We would be sitting really good, and it wouldn't cost us that much. Right now, there's 3 ways of being able to tap the energy. We have the tides, we have the waves, and we have the thermal. The one most people know about is the waves, and that's the first one I would like to discuss. The way we do that is have buoys placed in the ocean, riding the waves, connected to the ocean floor, which would have some sort of power line, either to shore or to a platform. And as the water goes into the buoy, as the waves go up, air goes out, it drives this little turbine, which powers this generator, and it creates energy, which works out pretty smooth. The other way is to have buoys halfway down into the water, and they're more like a piston, like in a car motor, and a cylinder. The piston goes up and down as the water drives it up and down, and it's also creating the energy. Now, the nice thing about this is, when they're underwater, people can boat on top of it, and it wouldn't bother it. But the other one, you wouldn't be able to boat on top of it. So that's one of the disadvantages, is some people like the ones underwater, because you don't have to see them, you don't have to hear them, and you can just want to deal with it. The ones on top, you would have to worry about as far as boats running into them. Well, waves is not the only way we can harness the ocean's motion. The other way is tidal turbines, which are much like the wind turbines you see in Eastern Oregon, the real big ones. They're like 190 feet around, and the wind at Eastern Oregon powers them. Well, the ocean's turbines, you can either be set up like this, or they can look just like the ones you see in Eastern Oregon, but they're smaller. These are only 45 to 60 feet around. You know why that is? It's because it doesn't take as much energy, it doesn't take as much motion in the ocean to power them, because the waters is 850% more dense than air. So the air, it takes a lot of air to push those things. Well, the ocean's so dense, it's moving all the time. It's coming through, and it's powering those bad boys like they're going crazy. The nice thing about these is since they're smaller, they're a lot less. There's a lot less maintenance on them. The wind turbines take a lot of wear and tear, and so you're working on them all the time. These don't bother the environment very much at all. And fish can pass right through those. Whales, not so much, but fish can. The other way we can harness the tides is by putting like dams over the bays or the rivers. They're called tidal barrages, but there's basically a dam. So what they would do is you would have something cross over, say like the South Jetty. You put this like a dam across it, and as the water comes in, it goes through the dam, creating power as it comes through. So it goes in, it fills up like a lake. Well, as the water goes out, this water says, "Ooh, it's going out. I want to go out too." So it goes back through and drops down into it and creating power again. So you get water coming in and water coming out. A couple of the big things about that is you need a variance of 16 feet between high tide and low tide. So you have a big drop in between. Now, right now, the scientists have figured out there's only 40 places in the whole world where we can do this. 3 of them right now already have these power plants. One's in Canada, one's in Russia, and one's in France. And France has got a big one. Russia is at experimental level, and they're still working on theirs. But right now, the scientists figure we could use this in the Northwest, but we dam a river. The problem being is, if you put a dam over the river, can the boats get out? Have a hard time getting the boats. So we're going to have a hard time talking the fishermen into you know, letting them dam the river. So right now we got to work on that one. Well, the first two were based on the motion of the ocean moving. The third one is the thermal. Well, thermal one is the one we know the least about. But the way it works is, you take the high temperature of the surface and the low temperature of the deep in the water, and the scientists have figured out a way where they create energy between the difference in the temperatures. You need a 40-degree difference. Well, I don't know if you guys know that, but that's a big difference between the highs and lows, isn't it? Well, not many places in the world have that. Basically, only tropical areas have that, like over in Hawaii and maybe Jamaica. As a matter of fact, this power plant right here is in Hawaii. And what they do is you're able to suck in the cold water, and they can bring it to the plant, and they can cool their plant with it, or they can just create energy with it. Well, right now, nobody's using it commercially. This is in the testing stage. So this one we don't know quite as much about, but they're going to work on it. Well, as we talked about, they're trying to replace coal. This is coal here. And we want to figure out whether or not the ocean's energy is a viable replacement for it. Well, I believe it is, because it's energy efficient, it's cost effective, and I don't know about you, but I don't like smelling all that stuff and breathing that. So right now it is. To use wave energy and the tidal energy, we can make it go for about between 4.6 and 7.6 cents a kilowatt. Well, to use coal or oil, it takes about the same price. So we could do it almost the same and do it better, with the environment being better. One thing about the ocean is, to wrap it up, is that the ocean is a renewable resource. Like everything else, that we have wind, we have the solar, we have everything else. The ocean moves all the time, 24/7, 365 days a week. It's just a renewable resource. I think it's something we really need to look at in the future. You guys have any questions? Thanks for your time.